So if you guys have any questions before starting, you can ask right now and we will answer that and then we'll move on to the session. And please do not start unmute yourself unless until you have any questions or like something. And you can post the question into chat window, chat box, and we will answer that. And this was the second session. The first session we discussed about brief introduction about machine learning, deep learning, and then we started about CNN. So anybody has any question here? Anybody has any questions? Anybody has not understood any of those concepts? We can revisit them. So I'm just summarizing the things. Like we discussed about what is meant by machine learning and what is meant by traditional programming. Then we discussed about what is meant by representation learning or deep learning, then how the machine is taking over and doing a lot of things compared to that traditional programming that we discussed. And then we discussed about if machine has to learn from the image, then how it will start actually, that we discussed actually. And we discussed about the image. So if you see this image, so we can see image something like this, but the way the computer looks this image is in terms of pixel. That also we discussed actually. So pixel means what is the value? This is the value of a pixel actually. Like, so this is number 9 1. These are all the pixel values. And if you see here actually, like so wherever there is a concentration of things now, so then you see the number varying. So this machine always thinks in terms of numbers. So this is how the machine looks. Then we discussed about what is meant by filter or kernel. Anybody has any question about the filter or kernel? Anybody not understood anything? So why we are looking for these filters is actually like what we discussed in the last class. Actually, we need to identify certain part of the images, certain features of an images. So we need to look into certain features of the images, and to look those features of the images, we need to have some kind of a filter or some kind of a layer which will look those portion and trying to identify those portions. So we that term is called a filter. So filter is actually something like you are trying to filtering out. So I'm trying to filtering out and only I wanted to retain something which I'm like trying to look into. The other term, other way to explain the filter is, see what is actually we heard about filter, correct? So you maybe heard about filter in day-to-day language. So I'm using a filter, means like chai patti is something that now. So you put that and the pure thing goes off and something unwanted will stay here, correct? So only what you are looking for, it will come this side, and whichever we are not looking for will stay here, correct? This is called a filter or like something. So this filter is also same thing. So this filter is interested in intention of this filter is actually I need to look into certain specific things. So if I'm looking for a beak, actually, like I'm only allowing certain things or configurations, certain information which is relevant to what I'm looking for. Rest all will be here only. The only thing which will pass out is actually which information. So that is the reason this is called filter. The other word for this filter is kernel. The other word for this is actually filter or kernel. So there is a two different things. And you know what is the input? That is the input in page. And what is the output? Means like this filter, whatever that filter is trying to put into that output. No, that output is called. It is called a output. It can also called a feature map. So and this will become input for the next layer. So how is that actually? Like if you see here a diagram of a CNN, so convolution neural network. So see, this is initially input and here the filter will be there. Output of this will be output, see filter will look into and create output. That output will become input for the next layer. So then for this is the input, and this input will then that will generate output. This output will be input for the next layer. So that how we can call these terms is actually we call this as a, either we can call this as output, or we can call as a feature map, or that will be in. So usually the usual term is a feature map. We'll call that actually, that we discussed. Any question here? Anybody is not understood any of these terms, because these terms are very important. So anybody is not understood any of these terms, let me know. Then the convolution we discussed. So see, the filter, kernel are both same, correct? So this is the kernel and this is the image. So I'm just using this image because this image is a portion where I'm trying to multiply. Dot matrix we looked into, and this is how the output. So what is that portion? See, this filter runs over that, actually. That also we discussed, actually. So how it actually happens, because of that reason, the word comes convolution. So if this is an image and this is a filter, so if this is 3 by 3 and this is a 6 by 6, actually, assume that like 6 by 6 means like I'm trying to draw something 6 by 6. I'm just summarizing it, actually. I'm not going deep. 1 2 3 4 5 1 6. This is 6. This is 1 2 3 4 7 and 6. So something like this, actually. So 6 by 6. So it's like what happens, what we are trying to do is actually this will convolve over this image. So this is the image and this is the kernel. So this is a kernel. So what I will be doing, so I will be convolving over that image. So I will be looking for this 3 by 3. So this 3 by this 3. So means like this is what I am trying to do. So I will be trying to, I will take first select this one and this one, and I will do dot matrix. So this is the input, and this is a normal thing, actually. This is a normal thing, and I am trying to do dot matrix, and that result, it will give one value, that one value, that is the output. So that is what is shown here. So that is what is shown here. What we so that is what is shown. This is the kernel and this is the image, and if you multiply, and it will give one result. So this is how. Anybody has any question here? So if you still not understood, so this is the another image. So it will try to explain. So let me run on GIF and see that like how it works. This is how it works, actually. Like, so this filter. So what is a filter? Filter is, this is a filter. This is a filter. This image. This filter is running sliding over this image. So how it does, actually, you can look into this. So this is how the it slides, and this is the output. So output of that. So this is called a feature map. It is generating. So we discussed in detail in the yesterday class. We discussed how this convolution, the filter convolve over the image, and how the output is generated, and this input size and this output size also we computed. Anybody has any question there? So, and if you want to see that like how exactly happens in the real image, this is how the real image happens. So this is how it looks like. So in real image, so that's what we look is a number. But if you look, see the same thing in the real image, this is how it looks like in the real image. It's like I will see a certain portion, and then I will see a certain portion. I will see a certain portion, actually. So this is how it will happen. Anybody's any question? Because I said no, image is also a pixel, correct? So if you see this one, actually, image is pixel. So in this case, I'm just using that number. In this case, I'm just seeing the image and then how the convolution is happening. So anybody has any question here? Okay. Then we understood what is meant by stride 1, and we understood what is meant by stride 2. So if you want to see that like how the stride 2 looks like, so this is how the stride 2 looks like. So it is skipping. So it is not skipping one, it is skipping two things. This is a stride 2. So this is how it will happen. So this is a kernel and this is the image. So anybody's any question here? Okay, that we discussed in the slide thing. So we discussed, and how to calculate the output size in the stride 2. We I have not given the equation. This is the equation you can use. So to calculate what would be the output. So for example, in this case, let me take an example, this one. So input size is how much? 1 2 3 4 4 by 4. So okay, so what is the input size? In if you say that like that is 4 by 4. So if you look for, and what is the kernel space? Kernel is 2 by 2. So if you see here, actually this equation, let me go here. So W, see W is the volume size. No? So this is the input size. So what is the input size? Is 4. So we'll take 1. So it's like I'm trying to calculate one side of it. So this is 4 by 4. So I'm trying to take this a 4. So then what is the F filter size is, what is the filter size here, actually in this case 2 by 2. So filter size is 2 by 2. So filter F is equal to 2. The filter size is 2. Then is there any padding here? There is no padding here. So see, padding I not discussed actually. So I will explain this padding, what is meant by padding. So P is means for padding. So we don't have a padding. So this is 0. So that is not necessary. And S is a slide. What is S is a stride? So here stride is equal to 2. So what is that actually? Stride is equal to 2. So this minus, so then stride is equal to 2. Then what is the equation? So equation is actually W minus F plus 2P divided by S plus 1. So what is that actually? So W here is equal to 4. 4 minus 2. 4 minus 2 divided by 2 plus 1. So this is how the equation looks like. So means like 2 by 2 minus 4 minus 2 is 2. 2 by 2 is 1. 1 plus 1 is 1 plus 1 is 2. So that is what we got. So one side is 2, another side also 2. Means like if you see there actually output is, this output is 2 by 2. This side is 2, 1, 2. This side is 2, 1, 2 by 2. Any question here? Anybody is not understood this one? So how to calculate? So this equation can also apply for the stride is equal to 1. It is universal, but equation. So you can calculate using equation, or you can manually also think about how this stride works actually. So any question here? So this we discussed and we also looked into. And we also looked into actually like how this works in the feature map. And another one concept which we not discussed in the last class actually is about what is called filters. Like, so there is, when we say that this filter, we are not saying that like only one filter. It may be having any number of filters. So the other thing is like we not discussed in the last classes. So if this is an image, in this image, we may have multiple filters. We may have multiple filters. So each filter is trying to look certain feature. So whatever it may be, initially maybe horizontal line, it may be looking, vertical line, it may be looking, or it may be looking for a curve, or it may be looking for a color in that one, certain kind of color, whatever it may be. So the each filter is trying to find out certain feature exists or not. So it may have any number of filters you can have. There is no such limitation that like you should have only one filter or two filters. So what, just to explain, I explained actually one filter. And also we discussed in the last class actually, the filter size may not be always 3 by 3. So 3 by 3, it can be 1 by 1, it can be 5 by 5, or it can be 7 by 7, it can be anything. So it can be even or even number also, 2 by 2, 4 by 4, anything. But usually odd number are preferred. And it can be uneven also. Uneven means like one side 2, another side 3, or 3, 2, anything. So that is also is possible. So filter can be any of thing. So there is no such restriction. But these, if you select these kind of features, filters, so your performance of the model will be good. So that we will discuss in the later on. So when we try to build a model, we try to check all kind of filters and see that like where I am getting a better performance. So we can see that actually. So, but don't have an illusion that like when I say filter means like always 3 by 3 or 4 by 5 by 5 or 2 by 5. It can be anything. And each filter has an objective. It is trying to look certain feature in the image. Anybody has any question here? Anybody has not understood any of these terms? So, okay. Now what happens actually if it is a multiple features, filters? So first this will look into and it will create an output, one feature map. And then this will look into and it will create another feature map. It's like, so what you can see is actually, you can see multiple feature maps. So when we see that one, we will have multiple feature maps. It's like, so this first feature is the first feature map, then maybe another feature map, another feature map. So if you wanted to visualize how exactly it looks like, so take about the color image. So I said actually in the last class, color image, whenever we say color image, it will have 3 channels, or the image is divided into 3 things. So how the color things looks like? So color image, whenever we say color image, so this is, for you it looks like a single image for visually. But if you convert how the computer looks like, the computer looks like one what is called matrix of a pixel. This pixel of what color, which storing the RBG, either R means like red, so R means red, G means like green, B means like blue, RBG. So
anything. So any combination. It's like for you it looks like a single image, but computer stores as a three 2 by 2 matrix. One matrix storing the pixel values of R, one matrix storing the pixel value of G, one matrix storing the pixel values of blue. Because using RBZ, you can create any color. So if you say if I'm using a pink color, so it is a combination of RGB. If you don't understand that, so let me go here, color code in terms of RGB. So RGB. So you look into. So this is how the let me go here. So this is the chart. So this is a chart of a color. If you see actually like this color, if you look this color, this is a combination. R value is this much, G value is this much. So it will say that like certain values. So if you say that like for this color, so R value is this much, G value is this much. It's like it will store one matrix of R value, another matrix of G value, another matrix of blue value. It's like when you say color image, it will have instead of one pixel matrix, actually it will have three pixel matrices, one for one color, one for one color. So why that is like that? Because the any color is represented using RGB combination. So this is color. Now, so if even if you go here, so this is the RGB combination. If even if you go here, it has RGB combination. It's like, so to represent this one, this pixel is represented in three different channels. So this is called channel actually. So this one is called one channel. This is one called channel because this is not called as an image. So combination is a called image. So this is a red channel. This is a green channel. This is a blue channel actually. So that is how. And this is represented as a number. So this is a number. This is another number. So representation is something like this. But this is just to show 101010. But actual value will be something like this. Actual value will be something like that, depending on which color. So R value starts from 0 to 255, G value starts from 0 to 255. So depending on what kind of image, if it is a HD image and all those things, the value may be very big or like something that like, so depending on that, the RGB values will be there. So anybody's any question, any color, see I'm saying that like this color, if you click here, this color red is 255, green is 255, blue is 0. So if you select this one, so something else. If you just select the red, rest all will be 0. If you just select the green, so sorry, blue, so rest all will be 0. If you just select the green, so go proper green. Okay, what is the proper green here? This is the proper green. So rest all will be 0. So fine. So now, so what happens actually? Like image is represented RGB. So when if RGB is represented, I will be having one filter looking for this, one filter looking for this, one filter looking for this. This is how I should be trying to create. So when I look at actually like I'm trying to extract certain feature from this one, I'm trying to extract certain feature from here. It's like, so this is what how I should be looking at. And that is the reason multiple output will be there. So this is how you'll be having this. Any questions here? Any question about how the image is represented in computers? How the image is represented? This is also very important concept. How the image is represented and stored in a computer. Anybody has any doubt here? Okay, so fine. So since this image is represented in a computer with certain kind of thing, now initially only what we thought about is two-dimensional things. Initially what we thought about is actually image is represented by two-dimensional things. Means like there is a width and there is a height. But because of this color kind of things, we also have another dimension, that is a depth dimension. So we have three kind of dimensions. Look, another dimension is width and height, we know. Another is a depth dimension. This depth is actually how many channels it has, image has. So in RGB kind of image, 3 channels will be there. If it is another kind of things like channels, like so this K represents how many channels are there in that image. So any questions here? Anybody is not understood any of these terms? What is meant by channel? What is meant by 2D and 3D? So fine. So don't consider this is a 2D, 3D image. What I'm talking about, how the image is represented in computer. So both are different. So 2D image is different, 3D image is that is different. But one image, how that is represented in a computer, that is what I'm trying to talk. So both are different. Fine. So okay. So this gives a little bit like overview about the image, because why we are processing image, because deep learning processes image and text and all those things, correct? So we are trying to see how the computer learns. So what is the objective here? How the computer learns from the image. The way we learn, whether computer is able to learn and recognize whether this is a bird or not, that is what is the objective. And because of that, we are trying to learn the convolutional neural network. And what is the convolutional neural network? That also is said actually. So then the next thing what we look into is actually, I said about the kernel. No, so why we need different kernels? What is the objective of the kernel? So if you wanted to see that like what the kernel looks like, we'll go a little bit deeper into the kernel. So for example, this is the image, and if you have the kernel values or something like this actually, if this is the image, and kernel values are something like this. So now what happens actually, like if you convolve over this image, if this image, this filter or kernel is convolved over this image, the output would be something like this. So see, original and output. So if it is only one here, so original and filter will be same. What happens actually, this is, if you want to see this actually, you can write a program and you can see it. Why this is, because at any point I'm just taking whatever that like. So for example, this is visually we can see, and you can even write a program. So if the kernel is something that like only center one and rest all is zero, so the original image and the filter image looks like same thing. So you can, it can be used in image processing and all those things you can see. So the second thing is actually, instead of that, if I have a value over here, instead of here, if it is there, so the original and the output image is shifted by 1 pixel. So this image is shifted by 1 pixel. That is how it looks like. So if you try out actually the manually, if you try out, because values will be shifted out. Like let me show you one with simple example. Let me say that like this image is having just I will take only 3 by 3, so that is easy to understand. So assume that like we have 3 value here, 4 is here, 6 is here, 8 is here, 9 is here, so 3 is there, 0 here, 4 here, some number, so 1 here. So now what I am trying to do, I am trying to do with the single initial one. What I am trying to do is actually initially this is 1, remaining was 0. So now if I do that actually, what would I will get it actually manually, you can try it actually. Now what happens actually, so let me do the how the convolution happens actually, and another thing is actually like I need to explain here is actually something called padding. So we should be doing padding to work on this actually, whenever like in real time scenarios I should, what is the padding means like, so I will be updating. So what I will be doing, so if I have to do work it actually entire thing, it has to convolve, I will be doing 2 paddings here, means like I will be adding 2 here, and I will be adding this side, means like, so it becomes 2 extra layers I will be adding, means like it 3 by 3 image will look into 5 by 5 kind of things, like so 5 by 5 it looks like. So that is how I'm trying to do into. So the padding of the image means like usually like I won't be doing this padding, I will be doing this here on padding, one side, this side, everything I should be doing one padding here. So what is the value here in this padding thing? The value will be 0 0. So values will be 0 0 0 0 0 will be there something. So all values will be something like a zeros. So now what happens actually, initially when I'm trying to convolve, it will be something like this actually. This is how I am trying to convolve. So means like, so what happens, so if I convolve over here and if I multiply, only this value 3 into 1 will be thing, rest all will be 0. So what is the value will come, it will come 3. So next time I will convolve over something like this. So if I convolve over something like this, so then what is the value I will be getting? So this 1 will be pointed over here, rest all will be 0. So value I will be getting is 4. So next what I will be trying to do is I will be trying to convolve over this. So I will be convolving over here actually. Now this one will be pointing here, so middle point, correct? So value will be 6. So if you see here actually, initial image value 3 4 6 or something like that, right? So rest all you can compute actually. It is just like it is exactly same as the original image. That is what I had told you in the first case. Like, so if in the first case, if this one is here, so original image and the output image look like same. Is anybody's any question here? Anybody is not understood like why the even after filtering that actually, like I got the same image that was the input. Okay, any question here? Okay, so we'll try the second one. So now let me erase that thing. So what I will be doing instead of this, okay, I will erase that again. Okay, now I am trying to write 5 by 5. So 1 2 3 4 5. 1 2 3 4 5. Okay, 1 2 3 5. Now, so what I will be doing, the inner thing I will be writing the number. So what is the values will be number. So number is something like a 3, whatever the number. So 4 random number, 9 6 3 2 1 3 1. So rest all will be 0. So I'm not representing, this is 0. So I'm just all are zeros actually. All these are zeros because padding I'm using. Now kernel, if what kernel I'm trying to use. So kernel what I'm trying to use is, I'm trying to use a kernel 1 here. So rest all is 0. So what would be the output? Now I'm trying to look into the output. How should the output looks like? So as per this slide, it should be shifted. So now let me see that like how things are happening. So now when I convolve over, like how the first convolution happens. So first convolution happens here. So first convolution happens 3 by 3, correct? So this is a 3 by 3. So this is how the convolution happens. So what is the output? What is the output here? So it will be it will be only 4 will come. So 4 will be here because rest all will be 0. So next convolution happens. So convolution is happening this layer. So this phase the convolution happens. So then 9 will come. Correct. So 9 is coming. So now how the convolution happens? Now this one is done. This is done. Now the convolution happens here. So convolution happens this one. Okay, let me use another color. That is better. So convolution happens this layer. So then what happens actually? If I convolve over here, the value will be, see initially like I got only 4 here because that is 4 value. Then I got 9 value. Now I'm trying to do convolve over here. So if I'm trying to do convolve over here, so I'm getting something like a 0. So I'm trying to get the values are something like a 0. It's like, so I won't be able to get the thing. So now if I try to convolve over here, so means like what you will be getting actually, like if you shifted the things. So this the values, see instead of the 3 here, so 4 is there coming, correct? Now one side kind of is shifting that. So one kind of values are getting shifted. So this, that is how the objective looks like. If you do convolution over that, there is something slightly shifted. So shifted left by 1 pixel. So shifted like one kind of pixels are get shifted there. So this is how the result looks like. So same thing can be done. And if I do something like the kernel 1 by 9, what happens actually? If I do, let me show the kernel 1 by, it does some kind of a blurring of the result. What is the blurring of a result? So I will be multiplying all these things. So let me do, and I will be taking average of that. So if for example in the same case, so any number, so assume that like in this case, the first case actually I am looking for, so 1 is here, 1 is here, 1 is here, 1 is here. So all this will multiply the 3 plus 4 plus 6 plus something, and then divided by 9. What is that actually I'm trying to do? Any number divided by a value, something like, what is the average? When you say that like average of something, so you are adding all those number and then divided by 9. So when you are trying to take that average actually, then the result looks like something like a blur. Blur means like what happens actually, I am taking this image color, this image color, this image color, and mixing, and the resultant value is average of these three color. Means like combinations, like average of these three combinations. Something looks like an visually, if you think about, actually it looks like a blur kind of image. So that you can visually like. So if you wanted to play with that, actually, like, so for example, if one sand of color, like, so red is 25, 25, assume that, like, now I am trying to take something that's like a 200, assume that like a 200, another value is 250, another value is something that like 150. So average is actually, average is something similar to 200. So if I'm taking a 3 pixel, so means like 1 pixel this value, another value, and another some pixel value, and I'm, instead of, this is a 200, this is 250, this is at 150, but here I'm representing average of that actually, and here also I'm representing average of this side, means like, so I'm changing the value with the average of values. So the result, well, resultant what we'll get is a filter, is a blur kind of things. If visually I'm not able to because you have to write a program and see the result in the program, because that is how the because you are not using the same value, you are taking combining, so you are blurring the image actually. So the depending on what kernel values you are trying to take, the resultant image will be different. So this, what, how can we check it actually? We will write proper code actually using Python, and we can check. So we can see the, take the image and convert into the pixels, and then write a kernel convolution of that, and generate the output value, and then print that image actually. If you do that, then you will be getting it actually, but that we won't be discussing here. If you are like going through the complete kind of curriculum, we will show that like how this whatever I'm explaining here. But if you are undergoing the complete course, actually I will visually show actually how the blur impact will happen. But right now I'm just visualizing, it's like I'm telling in a rough way because of averaging. So what is that actually I'm trying to do? I'm adding all element and then I'm dividing. It's like I'm getting a average effect, and that is because of the image looks like a blur. But practically, if you wanted to see, you have to write a program. So that I cannot able to do right now. But if you are enrolled in the full course, actually, we'll show actually how this impact of the kernel looks like. Actually, we will write one program to see how it looks like no change. We'll see how the left shift happens. We'll see how this blur things are happen, and we'll see that something. So all those things we will practically do the small code and see the end result. But here just I'm trying to explain you. So I hope you understood. Any questions here? Because the intention here is actually like I am trying to say that like depending on what kernel values you are selecting, you are selecting certain features from those things. Detailed things we'll discuss later on. So fine. Okay. Same thing. The was only these kind of kernels. Maybe different kernels are there. Another kind of kernel. This kernel values are called vertical edge detector. So means like what happens actually? This, if you see that actually 10, and this is says 0. So let me show that what is the 10 looks like and what is the 0 looks like. So if I say 10, so if I values will become the gray and something, no. So let me, what is the value of 10? If I represent 10 here, so let me do 10 here and 10 here and 10 here. This is a 10. So this is a value of a 10. So everything I am trying to represent 10. So this is how it looks like. So white kind of things. If I do 0, so if I say 0, 0, 0, so 0, 0 is something like this. So this is a 0, 0. So 0, 0 color and white color. Like, so if you see this image, so something that like this 10, 10, 10, 10, 10 represents something like this. So 0, 0 represents something like this actually. So, and what is this kernel looks like? So what I'm trying to do, I'm trying to take, so I'm trying to, so this is one here, 0 here, and this. So this kernel is called vertical edge detector. Means like what actually happens actually, this detects vertical things. So if you see here this diagram, this side is 0, this side is 0, its the middle values will be something like a number ones. So it's like it is trying to extract. So if you what visually see here, actually this is the blackout. So only I'm looking for this feature. So it's like only this kind of information will be filtered out. So remaining all will be. So if you try to multiply, this is how I should be getting it. So what is the end result? If you see, so end result actually I'm trying to find out, is there any vertical edge? So if you are not able to understand that, this is how that looks like. So if you, this is an image, in the image like a 4, and if you apply this kernel, so it will able to try to identify, so there is something like a straight line here, and there is something like a straight line here. So this kernel is trying to find out a vertical edge. Means like I'm trying to find out something, a vertical edge existed there. Means like why we need to look into those vertical edges actually, because if you think about anything, so see this 4 main, how many vertical edges have? It has one vertical edge, and this is one vertical edge. So this is the features of a 4. So I'm trying to extract, is there any vertical edges are there? Vertical edges are there. Means like I'm trying to figure out, okay, there is one vertical edge and there is one vertical edge. So means like 4 needs what? 2 vertical edge and 1 horizontal edge. So I will be using some kind of color. Then how it will be, color values will be selected, all those things that we will discuss, because all these values will be randomly selected, all those things, because I don't go in that depth, but I'm trying to just explain you. Kernel values will, depending on what values are there, so certain portions or certain information will be extracted. So if certain values are there, certain information will be extracted. Certain other values there. So if the value is something like this, so if values will be something like a vertical edge actually, if value is something like this actually, so 1 1 here, 0 here, -1. So you will be able to extract the vertical edges in the images. How many vertical edges in the images? If you wanted to see the real image, how it looks like, so let me show you. So that vertical edges, if you give this image actually, the kernel, that vertical kernel I say no, so that will only notice this vertical lines actually. How many vertical lines are there in the images? Not bothered about anything. So if you are looking for horizontal, it will only look for how many horizontal lines are there. So any questions here? Because this, because what we are trying to do, everything is a black box here. In deep learning or machine learning, everything is done by machine learning. Machine does that actually. I am trying to see what machine is trying to look. Machine only decide kernel, machine only fix the value of a kernel, but I need to understand like how the machine is trying to understand, because I'm not writing any rules, correct? So if you see here actually in the deep learning or something, so everything is done by the machine. All these features, simple features means like vertical line, horizontal line, curve, color, all those called as simple features. This complex feature means like clubbing those simple features, becoming a complex features. Like for example, in the letter 4, so simple features is, so one vertical line, another vertical line, sorry, and another one is horizontal line. So I detected one vertical, I detected another vertical. So vertical the filter edge detector will say that like I got this, and another, this is called simple feature. Then another filter identify, I have find it horizontal line. Then this is called simple features of the images. Then what is the complex features? Then it will find out actually how they are interlinked. And okay, totally in that image, I found out 2 plus 1. So together I saw these things, and then the image. It's like later on, if you look into the kernel images, they will try to get a complex features. So this is how the machine trying to understand. First, machine try to understand the simple features, then the complex features. How it will try to understand? Because of those kernels. What is those kernels? These are the kernels. So it is trying to understand certain features of the images. So deeper kind of things, like I may not be able to go and write program, because this is a short workshop. If you are enrolled in the full kind of courses, like we'll explain actually like what is how the output looks like. We'll write a small piece of the course of code to understand the whatever I'm trying to say here. So just I'm trying to use vertical edges. So what about the horizontal edges? So if I'm interested in the horizontal edges, so this is the kernel for horizontal. Let me go here. So this is the kernel for horizontal edges. So if you see here actually, this one, this side is 1, this side is -1. And if you want to see here, so this side is 1, and this horizontal is 1, and minus, this is mid between is 0 and -1. So this is called, I am trying to get the vertical, horizontal edges. So I am trying to find out a horizontal edges. It's like if I give the horizontal kernel, I'm trying to filter out, convolve over this image using the horizontal kernel, edge kernel. So then I will be trying to find out a horizontal line here. So means like one vertical edge kernel will identify vertical lines. Horizontal things will be trying to identify horizontal lines in the images. So depending on, if I'm trying to use this kernel, I am trying to get the average values of that, means like blurred of things. If I'm trying to get right shifted, left shifted, and if I'm just extracting the original picture. So depending on what kind of kernel you are trying to use, so certain kind of features are extracted from the images actually. So certain kind of features are extracted. It is not that like only those combinations are there. There are more other combinations also there, like 1 2 0, 1 2 1, and -1. What is that actually? I am trying to give more weightage for these middle things. So this is called, this will give the Sobel kind of filter. And this is another called, so any different filters will try to extract certain kind of things. Because if you wanted to go deeper into that, write a small piece of code and see that like output, how the output is converted. What you should be doing is actually, so you take the image, so this image will be converted into pixels. So pixels, and then you define the kernel, whatever I'm trying to show, then do the convolution. This filter has to convolve over here and gives the output. So that you will get an output result. This output result is also pixels. Then if you print this, so display this one actually, then you will get those kind of results. This is a picture. So then converted into pixel, and then I have done that actually. And this is a pixel, and that pixel values I should be converting into image, and I will be displaying. If you do the display those kind of images, this is what the impact you should be getting into. So if you use horizontal kind of things, so if see what happens actually, if you use this is a number, or like, so this is a horizontal line. So if you are looking, you wanted to interested in horizontal line, this kernel you can use, either this kernel or you can use this kernel, both are same. So what is the difference here? So I am trying to either zero out, either I am trying to enhance this. So but what I am trying to is actually I am only interested in certain kind of things like this and this and this. Means like I am interested in only the mid kind of thing. So vertical will be completely opposite of this actually. Means like what is that actually? This is this side and this side. So depending on what you are trying to look, so certain kind of features are extracted from the image. And this is 45 degrees. So if you see here actually, this is a 2 and rest is negative. This is 135 degree, this side. So if you see actually, this is how it looks like. So this will extract the 35 degree, means like in the image. So what I am trying to say, if image is something that like, if you something that like here, so 7 is looking for this kind of angle, correct? So one is horizontal line, another is something like an angle line. So if it is angle line, then this will be detected. So 7 can be written something like this. So means like one horizontal, one vertical, or one horizontal, one something like a angled. So means like if you use what is called vertical filter, so this will detect, but this won't be detected in vertical filter. You need an angled kind of filter. So multiple combination, because I need to find out whether there is an angled kind of curve. Like so, this is 45 degree. Opposite of this is 145 degree. So this is 135 degree. This is 135 degree. This is 45 degree. Whether 45 degree line is there or 135 degree. So these small features I am trying to look into initial kernel. So depending on what features you are trying to look into, certain kind of kernel values will be defined. So looked into. Anybody is any question so far? So you wanted to see how exactly the image specific filter adjusts. So if you wanted to see that like the impact of that visually, let me show you visually how exactly it looks like. So let me go to one site actually. This is the where I will be trying to find out. So for example, this image, I said no. So this image I wanted to do blurring of that actually. So if you say blurring of that, this is what the looks like. So this is how I am trying to blur the image. So this is the input image, and what I'm trying to do it actually. So you can try out. So this is the input image, and I'm trying to blur that. So if you wanted to sharpen that, so if you wanted to sharpen that actually, so this is the kernel value. So I'm trying to sharpen. So it's like what I'm trying to here, this is somebody has written the code. I'm just trying to change the kernel value. So top sober, bottom sober, like I'm trying to use certain kind of values, and I wanted to see how the things happen. Like for example, if I'm trying to look only horizontal line or some kind of line, so this is how it looks like. So if the kernel is something like this actually value, the image looks like something like this. So if kernel values are something like this actually, the image looks like something like that actually. So if kernel values, so you wanted to customize, and if you wanted to write actually, So this is what is the same as the original image. And if you wanted to see that like it is shifted here, so let me do that is how the shifted thing. So if you want to do that one, if you wanted to do, it must like you can do all the things possible, whatever you wanted to. So this is just like somebody has written the code. I'm trying to play around with this. So if I use different colors, then how the image looks like. So original image, how it looks like. If you wanted to choose your own file, you can choose your own file and all those things, but I'm not going there. Actually, it will take a lot of time, but you can play around with this tool. Somebody has written the code, so you can. But if you want to write your own code, you can also write your own code. So just I wanted to show that like how the uh, uh, kernel extracts certain features from the images. So depending on what kernel you are trying to find out. So now it is 3 by 3. If you are looking for 5 by 5, you can write code yourself, write a code, and you can do those things. Any questions here? Anybody is not understood this concept? What is the kernel? How the kernel extracts certain features from the image? Anybody is not understood? Anybody is not understood this concept? So this is the one good tool you should be playing around with if you are wanted to know. Any questions? Okay. So what I'm trying to say here is actually, if you take an image and apply specific features, certain kind of output will come. Either it will detect an edge, either you can do blurring of that and other things. So that we will do. And if you wanted to see that like how exactly the whole convolution layer looks like, so if you are interested into look into how exactly, because I'm just looking at one kernel, if you wanted to look into your entire thing, so you can try to do. So this is the input image. So then this is the kernel size, and this is I said now padding, no. So if you add a padding, then how it looks like. So increase the padding, then what it looks like. So this is a padding actually. I'm added a one padding. One padding is like every side is one. So then how the output looks like. So you can, so input size is something that like 10 by 10, and kernel size you can decide 3 by 7 by 7 or whatever it may be. 3 by 3 if I'm looking into, then you can see that like stride is how that, then how the output looks like. So this you can play around and you can see that like how things are working. If you wanted to change the stride, then how the this work around. So how things are looking into, how the output looks like. These are the two tools to understand, visually understand how the convolution works, how the padding looks like, and what is the output and what is the input. And this tool, other tool, what I said, no, this is about the depending on which kernel values. So what kind of features it has extracted. These are two very important things. And if you think about me, so think about that this knowledge, only 10% or 50% of the deep learning people have this knowledge. Rest all people just blindly understand what is the kernel. But if you wanted to become experts in that, you should be focusing more time on this and you understand in detail. But only 10 to 15 or 20% people knows that understands this much detail. But if you further you can wanted to go, you can go further details. So any question here? Anybody has any questions about the kernel? What is the kernel or filter? How the filter works and how it try to extract certain specific features. So what we discussed so far is actually we discussed two things. One thing is actually what is meant by convolution, and the second thing is actually what is meant by filter and impact of those filter and what kind of feature map it creates. So output is a feature map. So any question here? So any question? Anybody has any question? Okay, we'll move on to the next thing. So I said no. So this is the input image. This is a square, and I can use any number of filters. So assume that like I'm using one. This is horizontal filter. This is another kind of horizontal filter. This is vertical filter. This is another kind of vertical filter. So I'm trying to look into. So what I'm trying to do, this horizontal filter will look up the bottom side. Is there any thing is there? Almost like it will identify, detect this portion, and this one will this will detect the upper side, and this vertical this side, and this will identify this side things. It's like what happens actually, each one filter will create one feature map. This is a one feature map, one this each one is a feature map. So this feature map is from this one. So this is how it will create it. So means like what happens actually, this one image will be seen by multiple features, and each filter will try to identify certain features. So later on, maybe we may club it to understand with, okay, I found out a square in there. I identified a triangle. I identified something. So individual initial information. This is the first layer. Only I'm discussing about first layer in the convolution layer. So if you see this diagram, how exactly works in the first layer. Later on, maybe combination of all things, and that will happen. So I'm not going in detail. So first layer, this is how it looks like. So I got certain filters get certain. This is very much complex things actually. Like you should wanted to understand visually things. You should try to understand, or else like you can just create a program answer. But understand, because why it is a little bit like a complex, because we can't get inside the computer. Everything is done by the computer, but we are just trying to see how the computer is trying to think, because we are not writing logic, correct? The computer is writing logic to extract these things. So I'm just trying to peek into that computer, and I'm trying to see that like how this computer is thinking and what information is extracting initially, what information is extracting. This is not done by us actually. It is entire thing is done by the computer. I'm just peeking inside the computer and seeing that like, okay, in first layer, what computer is trying to extract? Oh, in first layer, computer is trying to extract only horizontal line, vertical line, and then what happens? Then it is trying to combine. So it's like in next layer, what is trying to understand? Another next layer, what is trying to understand? Third layer, because that is how I'm trying to look into, because that is all done by the neurons. Like, so computer is trying to mimic how the human beings. I'm just trying to understand how it is extracting things. I'm not writing any code there. I'm just trying to understand how the computer executes this program and trying to detect. So I'm getting inside the computer brain to understand how things are working there. Brain means like how it is executing that. Any question here? So if you want further kind of things, maybe we will discuss in the later half, actually, like visualizing how to display this each kernel and see that like what computer is thinking, all those things. This is called visualization. This is called some kind of called a distilling model. Actually, distillation kind of thing. Model distillation is another term is used. So but you are not interested, correct? We are not interested. What we are interested is in computer is actually, I have given input and I have given the label and asked you that like you identify whether it's a square, it is a triangle. I'm not interested like how, because computer does everything. But if you wanted to understand, then you should be peeking inside, and you should be able to understand those small features, how computer is trying to extract the things. So I'm trying to understand how computer is behaving. So any question here? Okay. So this much, because this is the speed I can go for, and if you have some doubts, actually we can ask. But if you are looking for a detailed kind of things, we will be discussing in maybe in the regular kind of sessions. So okay. So what exactly is there? Only one layer will be there in computer? No, multiple layers will be there in convolution. This is the input. There is one convolution layer and another convolution layer in between, maybe pooling layer. We'll discuss what is the convolution layer. We already understood. This is the convolution layer. So many filters are there in that now. That is a convolution layer. So one convolution layer, and then we are not discussed about what is meant by pooling, what is meant by ReLU. So we'll discuss. So computers will have in CNN convolution neural networks. So many layers is possible. What kind of layers are possible? Convolution layer. That what convolution layer then we discuss, and we have to discuss what is meant by pooling layer, and we have to discuss what is meant by other kind of flattening layer. So this is one type layer. Pooling is another type layer. Flattening is another type layer, and these kind of fully connected layer is another kind of layer. So many different kind of layers are there, and each different kind of layers will behave different features. Like, so they will do certain kind of activities. So we will understand one by one. So far we understood about the convolution layer, and what exactly this convolution layer and the pooling layer, all these things, they will try to extract certain features. Means like they're trying to extract. So means like maybe they're trying to understand the some kind of a features of an image. So and then finally trying to understand like how exactly it looks like. So something that like, so think about this is whole is a black box. So what we see that like this is whole exactly done in the computer. So only thing what we know is actually outside thing. So I am giving input and it is trying to predict. So what is this 0.2 means actually? 0.2 horse, 0.7 zebra, 0.1 dog means. So if you give this image to computer and computer is saying that okay, I am seeing 20%, means like 20% this looks like a horse, means like 70% it looks like a zebra, 10% it is looks like a dog. So why that combination? Why it is identifying 10% as dog? Dog also has a 4 legs, this also has a 4 legs. So if it is identifying dog has 4 legs, one feature. Like so, dog means like oh, certain features are matching in dog also. That is the reason it is 10%. So not entire features are matching. Means like so, what I told you in the first class, we called actually computer try to extract certain features. No, so what is the features of a horse? What is the feature of a zebra? What is the feature of a dog? So in terms of leg, so all having a 4 legs, correct? So is everybody has all animal has a tail? Yes, one tail, one tail, one tail. And what is the height? Height, this may be different, this may be different. What is the color? So color may be changed, and so mouth may be changed. It's like so certain features will be common. Like so, if just I'm trying to identify how many legs are there, so then 4 are there. So that because of that reason, so okay, this also certain features like I'm matching. Okay, there also 4, here also more. Because of that reason, computer thinks okay, this looks like maybe 10% looks like a dog. So this looks like something like a 20% looks like a horse. But finally, what happens actually? Whichever is the highest value. So something like a softmax is there. I'm not going in detail. So you understand that softmax. So what softmax does actually, it will enhances the higher value and suppresses the lower value. So what it does actually, so for example, for a softmax, if you give 0.2 and 0.7 and 0.1, so and you apply the softmax to this, means like softmax function. So there is a function called softmax. If you apply this function, what happens actually? This one suppresses the lower value, means like this will become 0. So this enhances actually, it will it will become 1, and this will suppresses, means like finally what it will classify, this will classify as a zebra. So this is softmax, and before the softmax value will should be something looks like that actually. So if this is how the convolution neural network looks like. How it that happens and what all this we'll write on sample code and we'll see. But detail, if you wanted to understand like how the convolution layer works and how the gradient and all those things calculation, I am not able to cover here in the workshop, but we will be covering that details thing in the regular kind of a sessions. But I'm just trying to say actually this is how the works. Like so, what exactly it works actually? So deep learning, if I'm giving the input and it is trying to output. So, but in between, what all things are happening? It is trying to extract simple features, complex features, and then it is trying to map into mapping from feature means like how many features are having so many features called certain kind of class, certain kind of combination of features called certain kind of another class. So that is how the mapping kind of something. I'm then roughly explaining, but it is much more complex in how it can computes. But I'm not interested in how it computed because anyway machine is doing. I'm just wanted to see how it is. But like that is how it happens. Like so, in example, in the horse or dog or something. So okay, 4 legs, 4 legs, 4 legs. Means like if I have to call horse, then it will have 4 legs. It has one tail, one mouth, and something. But color, height is this much, length is this much, and the color something like that. So it's like so many features. Like so, then that feature that is called feature mapping to the result. Actually, this is what is done in here. So this is how it will be done. So multiple layers. Any questions here? Anybody has any questions here? So we'll see how exactly executed by one. So far only you have seen the kernel. Means like what the one convolution layer looks like. So any questions here? Anybody has any question here? Fine. So this layer, whatever these layers is called feature mapping layer, means like why it is called feature map or feature extraction. So feature extraction is like I'm trying to extract certain feature from here to here. So still this layer is actually I'm trying to extract the feature. It's like I'm trying to understand certain feature here. And this layer is actually I got the feature, but I am trying to say combination of that. What is necessary to classify this as a dog. So this is called classification layer. So what is that actually? This, if you see this diagram, so this diagram is where we are trying to say is a mapping kind of layer or classification layer. Means like that is what the combination happens. Like I said, no, 4 legs, one tail, this color, this side, this is all. If everything features whatever is necessary to call this zebra is there, then okay, 70% features are there, which I'm identified actually similar to the zebra kind of features. No, I can call this a 70% kind of zebra. So that those layers are these layers actually. So the feature mapping kind of layers is what I'm trying to say. Those are these layers. This is a classification layer. So in this place actually, here I identified the feature and I'm trying to map feature and combination kind of things, and I'm trying to give the output. And after that, I will be trying to, this is called probability distribution. And on that, I am applying the softmax and I'm trying to do something called a Zebra. But this looks like much more complex. But if you wanted to see how exactly the code is done, the code is much more simpler. Like, so let me execute some code, and I wanted to show that like how things are executed. Let me go here. So let me execute one program. So we were here, okay, we were here. So we find out the what is called a feature map, width and channel depth, that all these things. Okay, so we'll try to execute one simple program and see how exactly it looks like. So let me go here. See, one thing is like these all things we should be understanding, but we may not be writing any code. So what is that actually? So here what I'm trying to do, actually this code is for identifying. So what is that image? So what is the digit is there? This code is actually to identify what kind of digit is there. So I said, so I will explain this actually when I'm trying to explain you the Keras programming. So these, see, if you see actually like what I am trying to show here actually, first is the input. So in this diagram, if you see here actually, first we should be seeing that like what is the input you are trying to give. What is the input we are trying to give is the image of size, certain size, width and certain height. So here what we are trying to give, we are trying to give an image of certain size. What is that size actually? If you see here actually, size is 28 by 28. If it is one, means like it is not, it is not a RGB kind of color thing. It is only gray color, means like only one color is there, gray color. So 28 by 28. So that is the input. So next, what is I'm trying to say? Then I'm trying to find out a convolution layer. What is that convolution layer? So if you see here, actually, this is the convolution layer. So how I'm trying to do, and how many filters are there? So how many filters are there? I have defined 32 filters. But what is those filters? I'm not defining. Computer only identifying. Okay, take 32 filters and identify which values, what kind of values it will be calculated. It is all left to the computer to decide. So I just asked you 32 filters. And what is the size of the filter I'm trying to say? Here I'm trying to say it's 3 by 3, correct? So here I'm mentioning 3 by 3 filters. And so now this is what I should be doing. So only this much I'm trying to do. Rest all is done by the computers. So for me to, no need to think. But if you wanted to understand, what is the kind of kernel, what features it extracts, how it extracts, then this theory is necessary. What is meant by kernel, multiplication, convolution, and everything. So if it is a horizontal kernel, what it will extract. If it is vertical kernel, what it will extract. What kind of different kind of kernels are possible. But you are not mentioning any of those. You are just leaving the computer. You only decide which kernels are better for these kind of models. Actually, I'm not defining anything. Then the max pooling. I will discuss about max pooling and another convolution layer. Now I'm saying that actually you look. Now here I'm saying that a 30 instead of 32, I'm having 64. So finally what happens actually, there is a flattening layer. So flattening layer means like, okay, till this extent, I have extracted the features. I have features here. So means like when we see here this diagram, so we will be having the features, like we identify certain kind of features and we identify certain things. Now the feature extraction is done. So feature extraction is done. Now I will be trying to classify that action. It's like I am trying to do how I need to predict. So this is a flattening layer. And then what I'm trying to do. So finally, I'm trying to how many classes are there. I'm saying that like how many classes are there in digit to recognize the digit. Digit may be 0, 1, 2, 3, 4 up to 9. Means like total 10 classes will be there. I'm just saying that like there are 10 classes are there. And I applied. So if I'm not applied this one softmax, then I would be getting something like a 20%. It looks like 30%, 70%. It looks like something other. So 10%, something like that. Let's know. So after the softmax, I should be able to get into. So this is what. So it's like only this is what I'm trying to do. Rest all is done by the computer. So when if it is executed and it is able to predict. So it is able to predict. So it's like this is how we should be doing the deep learning code. Coding wise, this is what we should be knowing. So it's like we should be understanding what is meant by layer, what is meant by mixed flow layer, and how we should be writing those kind of scenarios. But if you wanted to deeper inside into them, then you should do all those visualization. If you wanted to understand what kernel, if you selected, how it looks like, if you want to see that like kernel line, what information, and if you want to see all those things, then you play around and you can understand. But that is not just you wanted to understand that actually. So in detail, how computer works. So I hope you understood little bit about convolution layer. So any question here? So just basic kind of a convolution layer, but this syntax and all those things I will explain when I'm explaining the Keras programming, because this needs to be explained in the Keras programming. So how to write this program, what is this program means, how should you write this program, and how to interpret this program. So this we will be explaining in the Keras programming. So it's like I'll be, when I'm trying to explain the Keras programming, that is the second week kind of thing. So I'll be explaining how to write this program. So just now I'm trying to show what is what actually, like in terms of image, and how in terms of the code. So there should be correlation. No, there is an input and there is output, and there is a layers. So convolution layer and all those things. So just I'm trying to show that actually, but writing we'll be doing later on. So any question? Any questions on the convolution neural network? So at least you get a brief kind of overview about what is the kernel, what is the thing, and let me see. Okay, it's done. So what we will be doing is actually in the next class, in the tomorrow's class, we will look into other kind of layers. What are the other kind of layers like we discussed here, correct? So many. One is a fully connected layer, and we also discussed about something like a one is a fully connected layer we looked into, and another is something like a max pooling. So if you see here actually pooling or max pooling, so what are the things we saw here? So one is the convolution layer, another is a max pooling layer, and another is a flattening layer, another is a classification layer. So we'll discuss the dense layer is a fully connected network actually. So fully connected layer. So this one, what it does, how it does actually, what is meant of flattening, we'll see what is meant of pooling layer, that is max pooling layer, and convolution layer anyhow we'll look into. So we'll discuss in the next class these parameters. We'll discuss these parameters of these features of a convolution neural network. So any question here? Anybody have any questions about the kernel and about the how the sample convolution neural network just, and what is meant by feature extraction, what is meant by feature map? Okay, this I not explain, and may I not explain the softmax and those things, but because the thing is like each one, if you wanted to go in depth, it needs like around 3 to 4 months to just understand deep learning. But since I'm trying to compress everything in, so 5 days or 3 days just to explain that. That is how the workshop will be there. But full courses, if you go, then you will be understanding each and everything in a detailed thing. But you can also explore that. But I'm trying to give all the important features. So what are the things you should be knowing? What is meant by classification layer means what? What is like we'll look into that. So this is a whole. If you understood everything, then you understood the convolution neural network. Just like understood what is the convolution neural network, and also you understood how to write the convolution neural network and do those objectives. Any questions here? So when I say classification, I hope you understood, correct? If I say COVID or no COVID is a classification. If I give an image and say that like I'm trying to identify this image as horse, zebra, dog, then I'm classifying that image. It's like identifying that actually. So which class it is, which image is that? That is called classification. That is the reason classification layer. So these layers are classification layers. So any question here so far? I'm not able to complete this fully connected. We will be covering this fully connected layer and the max pooling tomorrow. And again, we will be writing a small kind of a code, and we'll see that like how things works in the convolution. So we'll see that like how the Keras program is written, and we'll execute line by line and see the result. So any questions here? So these are the key things you should be remembering in the convolution neural network. What is meant by convolution is the one first question they will be asking. Then what is meant by convolution layer? What is meant by pooling layer? So if you go the diagram here, so they will ask actually what is meant by feature extraction layer means what? What is mean the classification layer means layers means what? What is a fully connected layer? What is meant the softmax? These are the things they will be asking if they have to hire you for a deep learning thing. So first they will ask what is meant by convolutional neural network, and then they will go into each thing. So how the image is converted into pixel, and if it is a RGB kind of image, then how the pixel will be there. If it is a gray kind of image, so what I have shown is actually gray kind of image. 20 by 8 by 28 means like this is a gray image. It is not a color image. Grayscale kind of image. So what is a grayscale? Then you explore, because I cannot go that depth actually. What is a grayscale means like it is having only white and black or grayish kind of image. So there is no color there. So then how to do that, and all those things they will be, you should be learning there. Any questions here? So I hope by this time at least you should not have any questions on what is meant by convolution and what is meant by convolution layer. Maybe I will also discuss about in the later session, if I have one more session there, about different type of convolution models actually. Like I only discussed about the normal one. There are so many different kind of convolution methods also there that I have not discussed actually, because I just wanted to cover the basic things about the convolution. But there are like spatial convolution, depth-wise convolution, so many different convolution layers are there. So different convolution layer, but I'm not going that depth right now. But you just what are the generic thing. So what I have discussed is convolution layer. So fine. So any question here? So anybody is not understood any of these things? Okay. So in tomorrow's session, we will be discussing more about other layers. So, and maybe final day, we will be writing one simple program and executing. And then next week, we will be discussing about the Keras, how to write a Keras programming. And that time we will be writing more and more examples. So using Keras to identify, do some kind of activities. So then the next week, PyTorch, we'll be discussing about how the PyTorch, same thing I can write in the Keras, using Keras programming language, I can do using the PyTorch. So I will explaining how to do using the PyTorch. So same model. So whatever the model I said now. So currently it is in Keras. So how to write in Keras, they will discuss, and then how to write into the things. Because why I'm discussing CNN is because when you say, when we use convolution D, so you should know what is that convolution layer means. So that is the reason I'm giving the brief about convolution, and then we'll be trying to do 1 or 2 samples, and I'll also give an assignment. So one sample assignments after teaching kernel Keras programming, one sample programming I will give, and one sample program I will give to assignment I will give to execute after the thing. And whoever is performing good, will also recognize them actually. So who has performed good or not, something like we'll recognize, and maybe we'll give some goodies there. So any questions? Any questions? So, okay, so if there is no question, we'll end here, and see you tomorrow.